Good morning, everyone. We're going to talk a little bit about ISAM today. Unfortunately, we're not going to be talking about large language models and AI, how it's going to bring about the end of the world. But today, we're going to have some objectives that come out to some key actions and recommendations in the report eventually that our working group will put up. We are going to explore, next slide. We are going to explore the advancement that we've made so far in the development of modular architectures for serviceable spacecraft, reusable systems, and sustainable in-space logistics. We're also going to talk a little bit about the different use cases, including life extension, robotic repair, refueling, and our favorite standards, specifications, and interfaces that help us have things talk to each other. We're also going to talk a little bit about payload logistics, getting things up to space and re-entry. I think the last report from last year was also talking a little bit about active debris removal, which will be, there's a strategy that's going to be coming out, and as well as a national strategy. I'm the bald guy up here. I'm the chief business officer. I've been doing space on and off for almost about 25 years now. I have been fortunate enough to build some of the first petabyte scale systems from space data, all the way to helping transform analytics that the warfighter uses to conservationists and climate scientists utilizing space data to affect life on Earth. I am now helping architect the idea around ArcAssist, which is a platform, a long duration platform that is starting with an atomic unit. This is the Cutter spacecraft. We use nautical nomenclature at ArcAssist to define what we're doing. And this is our first free flyer. This is our one wedge of 6 sides of a hexagon. And the hexagon is what we call the port module. And the port modules can aggregate and assemble to many port modules. So one port could be one or more port modules. This is how we envision how this would work. We can take advantage of not just our own spacecraft, but other OTV providers to rendezvous and dock with the port platform. And we can also then deploy new spacecraft from the port. And to briefly touch upon scale, we are quickly iterating through our technology to build something I think is very special, where we're agnostic of the use case or destination. And this is the vision for global commerce while we expand into space. So with that, I wanted to introduce Kevin. Kevin is the Director of Business Development at Benchmark Space Systems. And I'll turn it over to you.
Wonderful. Thank you so much. Good morning, everyone. So I'm Kevin DeMarzio. I'm the Director of Business Development for Benchmark Space. We're a mobility products company that primarily deals with space propulsion technologies ranging from CubeSats. Sorry about that. All right. Ranging from CubeSats all the way up to, say, Espergrande class size. We primarily deal with chemical and electric propulsion and a little bit of GNC software systems. I've also previously was the Vice President of Business Development for Redwire Space. So really dealing with the commercialization and technology development for ISAM, OSAM, going back to IRMA all the way back in the day. So we've had many acronyms over the years, and I'm excited to see more as we go. Next slide.
Next, I'm going to introduce Josh Bowman. He's the GNC engineer at RIA Space Activity. And I will turn it over to you.
Is this working? Okay, cool. All right, so yeah, I'm Josh Bauman. I am a GNC engineer. Most of my experience is related to human space flight, specifically rendezvous proximity operations missions. Rather than talking about RIA Space Activity today, I'm going to talk about an exciting project that we had in the news this week. It's called Spitzer Resurrector. So Spitzer Space Telescope was launched in the early 2000s as part of NASA's Great Observatories program. It operated until 2020 in an Earth-trailing heliocentric orbit. We retired it in 2020, put it in a deep sleep as it drifted behind the sun from Earth's point of view. And we are proposing a servicing mission to fly out and meet Spitzer when it emerges from the other side of the sun in 2029. The mission is going to demonstrate a lot of servicing capabilities like deep space optical navigation, rendezvous with non-cooperative targets, and doing some data relay with the satellite that is no longer really intended to talk straight to Earth. So everybody should go look it up. There were lots of cool articles written about it this week, lots of cool graphics. I guess it's also worth noting that we are working with some of the original principal investigators on the program out of Harvard and Johns Hopkins APL. So we feel like we got a pretty good team together for this.
I'm going to introduce the venerable Jim Caravala, who's a CEO of Offworld.
Thanks, Dan. Offworld is building swarms of machine intelligent robots. We're deploying them initially terrestrially. Our first sector is the mining sector. So our robots operate underground in comms and GPS denied environments, deep collaborative intelligence, machine learning, and swarm autonomy. So in many ways, we've been doing ISAM for nearly a decade, in-surface assays and mining robotically before we go to then the space ISAM. And because we're building a modular industrial robotic workforce, this allows us to develop these swarms of robots of different species, use the common platform and intelligence layers to embody this industrial robotic workforce, which is like a ruggedized Lego kit that allows us to then build any kind of robotic system for in-space or surface operations, either inside or outside of a gravity well. Our current space contracts and deployments include lunar surface contracts, both with NASA, Luxembourg space agencies, and the European space agencies, predominantly around lunar mining and extraction of water ice, and then processing of materials, as well as developing of autonomy in those extreme environments. Thank you.
I'm going to introduce Troy Morris, and here he comes running down the aisle. Troy is the Director of Operations at Cal Morris Incorporated.
I counted chairs and didn't see there was enough for me, so I thought Casey had reshuffled me. So if we go to the next slide, please. So for those that were here on Monday, I'm one of the elite companies, KMI. We are focusing on uncooperative, uncoordinated, uncontrolled objects in orbit. So if you go to the next slide, we'll talk a little bit more about how. So our main technologies come together on a spacecraft known as LALAPS. This is a rideshare compatible spacecraft, so we can get to many orbits in a variety of different unique ways to go after unique objects. Yes, we are the people that put out the priced playing cards at Space Symposium a few weeks ago, but the key pieces of technology is the software that characterizes uncoordinated, uncontrolled, unprepared objects known as Tumblr. That allows us to approach, in this example, a rocket body, but use your creativity. And then we use the hardware that's shown along the bottom known as Reach. That's currently been developed in lab that came out of a DARPA NASA JPL lineage. This is one of our orbital prime contracts that we've completed, and it is going to the ISS at the first launch of next year inside the ISS. So really focused on the known unknowns of space right now and how we can help.
The Donald Rumsfeld, the unknown unknowns. I'm going to introduce our last but not least, Brad Berkson from Milespace, the Chief Operating Officer.
So, as probably the only direct report in the room to Donald Rumsfeld, he would appreciate the quote, God rest his soul. Could you go back a chart? I'm not ready for that. My background, I served as the Director of Program and Analysis and Evaluation at OSD for 4 years in the Bush administration and shortly into the Obama administration. That job is $3 trillion of your money and deciding who gets it. Before that, I was the Acting Deputy Undersecretary of Defense for Logistics and Material Readiness. That's about $200 billion of the top line and 1 million people that are in the DoD that do that. So a couple jobs in there. Serial entrepreneur. After I left the Pentagon, I was on Boeing's defense board for a few years. A startup in nanotechnology out of Cambridge. It was MIT nanotechnology. And then 2 years ago or so, I joined RocketStar and then eventually Miles Space. RocketStar is an aerospike launch provider, and Miles is a in-space propulsion provider. So now we can go to the next chart. So here we go. We are pleased to announce the first practical application of nuclear fusion that will not annihilate humanity. And being a native New Mexican, I take a lot of pride in the ability for our country to annihilate humanity. We did most of that here, and we're glad to have a new way of using this wonderful technology that has maybe a little less damage to everybody. It uses a unique kind of fusion. The fusion's called proton-boron fusion. Proton-boron fusion is atypical. It doesn't happen in the sun. It's not what we typically call fusion. It's not what the National Ignition Facility in Livermore does. There's a unique aneutronic fusion called proton-boron. If you have a high-speed proton and you hit a boron atom, it'll fuse into a highly energized form of carbon that decays instantly into 3 alpha particles, depending on the isotope of boron. It'll also create gamma rays and other isotopes. In the context of an electric propulsion unit, electric propulsion typically uses ions that are created in the propulsion unit and ejected from the unit. And they end up creating a dense charged, positively charged ion field immediately behind the engine or the propulsion unit, which causes problems because the next ion trying to get out is being repelled by that ion cloud. So the presence of these alpha particles going in all directions clears that exhaust, as you would think about it, and reduces the friction or the electrostatic pushback of the ion field, and therefore makes the engine or the propulsion much more efficient. Our base thruster, which Miles developed, is a water-based thruster, and one of the species of ionizing water is a high-speed proton. So we're fortunate to have kind of the perfect base thruster with a very unique form of fusion that we validated the fusion. We get the alpha particles, we've got the gamma radiation. We're doing an SBIR phase 2 right now with RIA as one of our partners. And we've proven the fusion, and we will test the final product in the next 6 weeks at Georgia Tech to tell you how much it makes it better. So that's us.
Who's had their caffeine? Raise your hand. All right. We're going to touch upon a couple conversational items. I'm going to go at a clip pace this morning to try to open up a lot of dialogue for later today and then through the week. I'm going to try to align the conversation to our last couple of years of reports where we have some key questions, general observations, and some key tasks and things that will come out from those as recommendations. Going into the first part of this, I'm going to split up the questioning to the panel. But these are the core topics that have come up throughout the last couple of years. And I wanted to kind of take some time to put them up on the screen to look at them and have some visuals, but we're going to open up some dialogue around these today. Again, no solid one answer is going to be the case here today, but that's what the working group is, to start forming some thesis around these core topics. So with the first topic, I wanted to talk a little bit about the strategy here. There's going to be eventually multi-domain, but also multi-theater in space. And how do we define a cohesive strategy? And I'm going to turn that over to Jim here as a first guinea pig to answer some of his thoughts on that.
Great. Thanks, Dan. So looking at a cohesive strategy for implementation of ISAM, what are our objectives? What are we trying to achieve? I think the long-term goal has to be, I think there's much agreement, has to be the establishment of commerce. If we're trying to establish commerce, the enforcement of free access to that commerce, we need delta V. And I mean, there is a term in mining around the principles of infinite resource, the infinite reef, the infinite ore body, where for all intents and purposes, the economic availability of your resource is inexhaustible for generations to come, at least in any meaningful sense of the economy. For in-space propulsion and propellant, we have that effective infinite resource, whether it's terrestrial, lunar-based or asteroidal-based propellants. We need to establish, I think primarily we need to establish the ability to execute infinite access to delta V, to be able to maneuver to anywhere, and then to have an interoperable architecture for what do you do once you've been able to physically maneuver to a location in cislunar space and beyond. And that can be functions such as grappling, docking, observation, rendezvous, etc. And once we got that functional breakdown, then it becomes, in the context of commerce and application, it becomes much more addressable to identify what are the pieces of the puzzle we need at any one time, and how do we create that toolkit together?
Troy.
So multi-domain to us is very intriguing because as far as humanity goes, we also like to leave objects behind. And it's something that, you look at history to today, to our first steps to the moon, we do the same thing. And so it's something that for us, focusing primarily on the debris aspect that threatens and can build the ISAM future here, we see this multi-domain of, all of government, all of industry. We like using these all of blank statements. And then we immediately section off the moon. We immediately section off LEO versus MEO versus GEO. And it's something that not ourselves, but there's some in this room that are looking at how can we do launch to these multiple domains from the same organization. And so our perspective is bringing these together. And I don't want to steal one of the future questions here, but of not how are we doing it now and where are we going, but where can we be and where do we want to be? I'm a big fan of history. JFK's Rice speech is still ringing in my ears almost every day I wake up and turn on the work computer. It was a big, bold claim that I'm sure worried many of the scientists in the room. And it's something that Artemis is trying to pull us there, but you don't get somewhere good by taking small steps. You plan for the big march and you falter along the way, but you still end up a lot farther than you started. So I'm more excited for some of these other questions. So I'll pause my comments there.
Thanks, Troy. Brad, do you want to weigh in there as well?
Nope.
All right. So we're going to move on to, I think one of the most important question here, especially looking at the last 2 years of reports, has been the perception. Where are we in TRL level? I did see, maybe Troy, you can kick this off, but the TRL level in the lab versus something that's operational. What someone can actually buy as a service or a product and get it up to some sort of operational capability. The perception is that it's a long way off. There's demos that have been happening. We've done demos. I think everyone up on the panel has done quite a bit of demos, but what is the perception versus reality?
So this is one of my favorite questions, especially with the deck of cards I've been handing out to some who are asking good questions. And I love the very, I'll say this politically correct, experienced perspective that yes, these will happen 2050. I mean, we were just seeing the sun experiment that's going to be happening. What was that, 2029? And that to me, in the current ecosystem we're seeing of new space, is politely far off. There is so much that is happening that is coming on term between the connection of VC to innovation to what's just happening in the fringes of university labs, that I think it's something too much of planning of, 5-year palms of these systems that we've built for a very good industrial innovation sense in this country are falling short and are falling behind of what innovation is actually moving at the speed of. I think if we had this conference 6 months ago, AI would be something to discuss. And now it's the forefront of most conversations because innovation is just continuing to accelerate. And so I think the perception of the decision makers is behind the perception of those in the trenches. And it's something that for the demos, all of us could take 20 minutes on stage and walk you through the dozen demos we have. We try and pick just one to show here. The demos are happening. It's just a question of whether government and major partners and players will listen.
I think just briefly again, I think everybody is in agreement about what are the nice to haves and what are the objectives in terms of achieving in-space capabilities for ISAM. What is lacking, and perhaps it's going to be touched on some of the other points, is a critical strategy that both government and industrial and civil partners can agree on and commit to and take risk on together, and risk their own jobs, is what is needed. We need people to not be afraid of making the wrong decisions, but to mobilize, to move forward at a pace so that we can continually iterate whilst we remember what the last mistake was, not 3 years downstream when everyone's forgotten. And that's the challenge. I think we need boldness, we need aggression. We've got enough vision, we've got enough ideas. I think we've said the same thing at the last conference last year as well, and the year before. I'm sure I'm getting deja vu, and I think I said that last year as well. What we need to do is just execute, and we need to execute boldly. And some people in government need to make decisions and be prepared to lose their jobs this time next year, or to reap the rewards this time next year.
Kevin, do you want to weigh in on that as well?
Yeah, sure. So I think the one thing I'd want to characterize here is the time frame. When I hear far off, to me, being in the space industry, far off can mean 10 plus years. But I think with space logistics and ISAM, there's been demos that have been going on for multiple years, and even active programs like MEV going and refueling a satellite. So being able to have that type of space logistics technology already out in the field, I would characterize it more in the sense of whether it's readily available for different size classes or exquisiteness of your asset. So if you're willing to pay up for the price of the technology and the bespoke way of performing today, there are options. But there are many technologies that are coming online over the next few years and being demoed today on the ground that I think is going to change the landscape and allow more, and I should say, reduce the barriers to entry for a lot of other organizations, both government, civil, and commercial. So the demos are here, and I'd say, depending on your time frame and depending on really your focused application, there's availability today to be able to go and do the actions that you need to. So I would definitely want to slice this up in understanding timeframes and technology and application, and really underpin that with there's many technologies being developed by a lot of different companies that are going to support that.
Thanks, Kevin. I think the next big question here on the board has been around design and architecture for ISAM specifically. And I'm going to, hot off the news, I do want to have Josh talk a little bit about the Spitzer telescope and what you're working on, how we might get around legacy design as well as architecting for the new. We'll talk a little bit about modularity later down the road, but I think that specifically has been a problem with things that are in the pipeline right now are being designed still specifically around legacy, and that how do we get ISAM embedded into some of those legacy architectures, but then also plan for the future.
Are we okay now? Okay. Yeah, so yeah, Spitzer Resurrector is going to resurrect an old space telescope. So I think that's the legacy part of it. But what we're proving on the way there and when we get there, I think is applicable today and in the future and in any domain. So we're getting to Spitzer using optical navigation. You know, we're going somewhere where there's no GPS. We're trying to demonstrate technologies that are going to be useful wherever you want to use them. When we get to Spitzer, we're not exactly sure where it's going to be. We haven't talked to it since 2020. And by the time we actually get there, it's going to be 2029. So there's a big region in space where we're not exactly sure where this object's going to be. It's not exactly telling us where it is. So we're going to demonstrate the ability to find an object when you're not exactly sure where you're going or where it is. Then once we find it, you know, other side of the sun's pretty far away. There are light speed delays. We're forced to have a highly autonomous rendezvous system. And so that's another demonstration that's useful around Earth, around the moon, deep space. We're proving autonomy sort of in one of the harshest environments that you could hope to prove it in. And then once we get there, we're going to do some near field reconnaissance, check out the vehicle, see how it's doing, see if it's still mechanically intact. So while we're working with an old system, I think all the technologies that we're demonstrating and proving on this mission are useful in any domain and useful on new technologies, even after these standards are established.
I'm going to turn this over to Troy as well. I do think part of the design mechanisms of Legacy have been to achieve specific missions, but now that we're getting to ISAM's full potential in terms of design, how do you perceive that dance that we have to do with objects we don't know? How do we find them and so forth? But then when we get there, what do we do? And how do we architect grappling and other mechanisms to account for that?
Yeah, so the standards and the lack of standards historically is always a very interesting position for us at KMI. We sit and confers on a few different working groups focusing on standards and other focuses. But as a company and you look at our technology, shouldn't we be the biggest advocates of like, no, take your time? Because the less standards that are out there, the easier it is for us to make a business case of, oh, we can grapple with things no one intended a standard for. But we're citizens of space. We're citizens of this country and we're citizens of this industry. So the way that we see it right now is that moving forward in standards just moves everything forward. We've developed our technology in that vacuum in a different aspect than RIA for where they're going after a known object, but where is it hiding in a multi-kilometer zone of darkness? So from our perspective, the grappling aspect with a unresponsive target, but also one that has potentially changed its shape, or there's even a variety of scenarios we're working out with some of our partners for objects. No one's quite clear what it is. It's bad. It's swinging past the ISS every couple of orbits and it's debris or otherwise. So from the KMI perspective, it's something that right now we're dealing with the repercussions of lack of standards, lack of ability, lack of in-space servicing. And we're addressing that right at the tip of going with as agnostic as we can. So I see it as the future that designing to these standards, whether it's through set government fund legalese standards or coming to cohesion together in industry and in the developing world areas, that makes all the difference in the world. If you had to go to a gas pump and you find your specific plug that goes into your specific car, I think Henry Ford would still be a poor name in Michigan. But we found some ways to bring some certain things together, finding different options for different scenarios. And so it's something that it's not a, should we? Yes. It's when and how long are we going to drag our feet before we kick off this next part, this next ecosystem over our heads?
So on the topic of standards, I would ask the question, I don't know the answer, but I would only ask the question of what are we trying to solve today and over the next 10 years by the establishment of standards? Is it reduced cost? Is it for some form of interoperability? Is it for some preparation to scale into hundreds or thousands of units? The establishment of standards is essential as the market grows. But I think there are, as we're pursuing that very laudable goal, there are also things that we can do in parallel to accelerate the ecosystem. And I do believe the ability for spacecraft to connect, to approach each other, to dock and rendezvous without standards, so non-systematically, is a function of actuation dexterity, machine vision, and applications of machine intelligence and autonomy. And it just so happens that those particular tools are on an extraordinary upswing right now in terms of their development optimization. So it might do us well to just keep in mind, as we're developing the absolutely necessary standards for ecosystem consolidation, maybe there are some pathways that we can take to accelerate our presence in space, specifically around the use of intelligence and autonomy in the machine environment.
Anyone else on the panel? I think the last part of this is doing that dance between two spacecraft or different types of RPO that's highly controlled. Export control remains an issue with the entire commercial space industry for right reasons. But when we start getting into nuclear, I'd like to open it up to Brad. What do you think here needs to be talked about in terms of opening up regulatory discussions for nuclear propulsion? Because that does open up quite a bit of use cases that we didn't have before.
I mean, that one word is going to generate a bunch of problems from export control, regardless of what it is. The best research, Sean, if I remember, is the Russians. So they actually done most of the work on this fusion. So in any event, I just, for that particular word, I have a problem that I'm not sure we're going to get around it, regardless of how ubiquitous or replicable, or it'll be patented, so it'll be public knowledge about it. But when we get cornered into the room by people carrying badges from the federal government, this is what exactly they're worried about. And that's what they talk about. So I don't have much hope on that, just the fusion part of it. I think in general, we've actually exported our base thruster and had pretty good success, again, to allies and friends. And export controls in a world where our technology is being attacked cyber-wise. Again, I think it's nice to think we have some kind of control, but I also would just try and move fast, because moving fast generally beats other things. As we were talking about standards, the slowest bodies that I've ever been associated with in my life are standards bodies. And so be careful what you wish for. Typically standards get developed by the first mover who has the most scale and becomes a standard by definition, as opposed to some group of people sitting around, because everybody has an opinion on it and everybody has a vested interest. So it's much more like a legislative process than it is like a kind of good outcome. I wanted to go back to the funding. We kind of moved over it. So I think everybody in this room should be very encouraged, because having been inside baseball on how money gets allocated inside the government and the biggest piece of the government, when you have the White House saying the same thing that a combatant commander is saying, and the two things I hear is, I need this done by 2030, that gives us some indications of when the timing is for this stuff, because they will get it done. If he says 2030, typically they will hit those kinds of things. What I learned at the Pentagon was not always great at integrating, but very good at executing. So you tell them you're going to do something, you give them a target, they typically will hit those milestones. Military system, a mission for a military person, that's what they do. If I was sitting in that debate, the other thing that's nice is the program managers have now been directed to focus commercial. So that's also a very unusual guidance. It's talked about a lot, but again, down from the chief all the way down, Secretary of the Air Force, they've all made this a very consistent argument. So not only will the funding come as the top line for the Space Force grows, the direction of the contracting officers is going to be towards commercial alternatives. A target has been set by, from the chief down and to the combatant commanders about how long and what they need, and everything in that whatever it's called, dynamic space maneuver operations strategy stuff is this. It's this topic. So I think we're actually in a relative to other million people vying for money on the top line in the Defense Department and the government. We are actually in one of the best positions for funding. And I think the other path to this is, remember, as she said, they're doing a 2026 budget process now. So think about that. There won't be money allocated for a lot of things till 2026. That money kind of comes in as a JUON, a joint urgent needs statement. Yeah, operational needs statement, JUONS. JUONs have the ability to circumvent the entire process. It comes from the combatant commander up, goes right to the services and said, I have this joint need. And to the extent there is a material solution that's in the market, it gets funded. There was a thing called MRAPs. We didn't have MRAPs before MRAPs were a thing. We didn't have a lot of things, but when the government has a clear need, they have mechanisms to get them fast. So to the extent the commercial market, and we have provided real tools that can actually deliver the needs of the combatant commander and the government, the money will eventually flow. And God help us if it really flows hard, because I don't think startups aren't typically the best people to take $1 billion. I remember when we were trying to allocate $2 billion to a cyber issue or something, and you ran through the numbers and think about building $1 billion institution in a year, how many people that takes and how long it takes. Just, it's a good place to be in, but it's a very daunting task to take that much money. So
thanks, Brad. I think with the time allowed here, I did want to call attention to no more than 6 is always the rule of efficiency here. So 5 bullet points here that everyone should take away, and we're going to talk about it throughout the end of our working group and then into the rest of the week. But these are things that I think we just touched upon, but calling attention to these things and having a visual for what ISAM truly can bring. It is glueware. It can tie together multiple strategies at once and accelerate ecosystems, not just one ecosystem, but multiple ecosystems, and accelerate downstream impacts. And so I think when we talk about standards, specifications, it really is adopting something that can talk to each other. It doesn't really have to be a standard. It can be, but it doesn't have to be. USB did not start as a requirement for the standard itself. It started because we needed something to talk to our computing device. We also need to think about support for demos through platforms that allow demos to accelerate at a cadence that we don't do right now. That will really start to affect a toolbox. Everyone here in the room can start to work together utilizing that toolbox, and transitioning those tools from demo to an operational capability is something that's a key takeaway that has been addressed in the report for the last couple of years, but has not actually been, as Jim was mentioning, we need to have tactical execution on that idea now. As export and RPO and all the other types of things that start to play out, we do need to think about the legal frameworks, as well as the laws to update, but also treaties and strategic collaboration, because this is not just a tactical power maneuver. This is economic power projection as well. And so we need to think about that from allies to the United States as the center of gravity here, how we work with that community. I'm going to leave it to some closing thoughts from the panel. And given the amount of time, we only have a few minutes left. If you have any more questions, come find us. Okay, great. Brad, we'll start with you.
I think it's an exciting time. This topic is probably the best researched and thought through, and it really provides, I think we've got the launch thing working. And so now the launch thing is working. What the military is saying, which is a reflection of the rest of the market, is okay, I get up there. I can get up there cheap now, but once I have to move around, I'm still on a one-way mission to death. I'm not on a can do multiple things, and it's not a truck driving stuff around. It's a, suicide truck. It's a kamikaze going and doing some mission and then dying. And I think that's the big change. And I think that's what this is really about. And, I think, again, we're fortunate because I think the money's going to come here, as well as the, there's already thoughtful work going on at the interagency level and policy level, which that's rare that there's thoughtful things that are agreed to. So anyway, I think we're in pretty good shape.
Yeah, I'd just like to bolster what Brad was saying. I think it's a really exciting time for ISAM technologies. And really, when you start to think about this, the beginning of this started maybe a decade ago with Restore-L and starting to figure out how we could really apply these various technologies to start doing these amazing applications, such as what General Olson pulled up yesterday, which really had a lot of interdependent technologies in the space industry for ISAM applications, moving through various ranges in our solar system. And so when I start to think about that, there are some underpinned technologies that really have been prevalent in the space industry for a long time, such as logistics technologies that really are going to support the foundation of all of these new ISAM technologies and applications. And I think that's something that really are being developed in parallel and are really pulling each other up by the bootstraps to innovate and to really get a higher level of technology than what has been available in the marketplace today. So it goes, especially coupled with all the different other pieces of technology that are available in the space industry today that have to be developed further and innovated on to really support these new ISAM architectures.
Yeah, so from my point of view, we were talking a lot about how there are all these, great demonstrations, but the perception's a little bit far behind. And in the next couple of years, I'm looking forward to seeing us overcome that hurdle of perception that these capabilities aren't at a point where they can be used. I think a lot of interesting technologies being developed, and we heard yesterday about some White House policies related to ISAM. They want to see more R&D with, the technologies that they're interested in related to ISAM. And it's great if we can develop those technologies, but at some point we're going to have to demonstrate them to prove to a customer that we can use them in a mission critical platform. So going forward, I'm looking forward to seeing all these new technologies get demonstrated, get their TRL levels, and get them to be something that our military and NASA can rely on when they actually need these capabilities in the near future.
I would recommend 3 points of action. The first is we need an ISAM flagship program that we can all coalesce around and push forward and engage our activities through. The second is that I think at the end of the workshops of this session and this meeting, we should have some KPIs that we define and we measure and we account for this time next year at this meeting. And the third is, I think we need to reach out to the automotive, industrial, and some other sectors and take stock of the latest lessons learned in interoperability, standardizations, and operation across differing architectures.
Being a company from Michigan, you couldn't be more right. So many of our engineers, we straight steal from Detroit, and the innovations that they're doing a scale of millions is something we're lacking a lot. So being last on the panel here, I did write some of my thoughts because each one of my colleagues up here had great ideas. And the first one I want to hit on my closing is Brad's point about $1 billion is a struggle to smalls, but we engage with smalls because quick innovation is a struggle to primes and government. So to transition tech, we all use TRL. Probably one of the most easy to understand ideas in aerospace, other than rockets go up, is TRL. And it's something that's great is we go and talk with different ideas of, hey, we want to bring this ISAM concept forward. I put it on my slides. Here's our TRL. But the unstated question that's always lingering on the decision maker's mind at the White House, the Pentagon, is what's the business readiness level? What's the BRL? And I think that's something that we really need to focus on as well as we're moving all these things forward. It's something that we have TRL. We want to be able to see maybe a BRL that comes with it. The second part there is then kind of tied to the end. For major flagships are great. I've walked past one at Goddard that's been there for 11 years. And sometimes these flagships are slow ships to move. So I offer a kind of contrarian, but not opposing idea of let's build the toolbox by including ISAM capabilities in every mission. We don't do a launch and learn nothing from launch. We don't have communications, have no experience there. Every mission is incorporating these concepts. And that's why we have such a, one of a dozen reasons, we have such a strong launch instance in this country right now. Is because every mission needed it. So as we consider ISAM as just this special case that only really use when we absolutely have to, that's the deep dark tool in the bottom of the toolbox the mechanic forgets about. As you use it and you become familiar with it and it's incorporated, this is why deployables is no longer much of a concern because we use it across industry. And so I think that's an area of innovation. It's not just the flagships, but incorporating ISAM into the everyday.
Okay, so we have time for one or two questions. Sure.
And I know you covered this. Oops. Is it on? Is it on? Okay. What regulatory legal hurdles concern you the most?
I think for us, the biggest one is, there's so many that I want to pick for, is probably international agreements. It's something for, we want to build stuff in space. We want to grab stuff in space. There's a lot of liability and differences between, as an orbital debris guy, if you gave me control of the world, I'm going after the Zenith rocket bodies, not because where they came from, but because the hazard they are. And one of the biggest blocks is not the country they're from, but just it's another country. So I'll pick that one and leave some juicy targets for you guys.
I don't know if it concerns me because it would be an oxymoron, but it would be effectively even the fact that rendezvous and approach is, effectively a breaking convention of foreign bodies, foreign objects and satellites. So I think whether it's a principle of salvage or a law of salvage, or just let's get on and do it, there has to be a frontier push of interacting with like nation state objects, and we'll figure out the rules of the game afterwards.
I wanted to just have some closing remarks. Thank you for the opportunity up here, Casey and the New Space team, and to my panel and the colleagues up here that had some insights, and we're going to carry that on this afternoon. Again, if you have any questions, we made it with about 91% eyes open, so that's pretty good. So we're going to call it quits here, but do find us if you have any more questions. Thanks.